Hello class, this is your well-rounded math teacher, Mr. Carr. We're working on Unit 3, Video 1, solving systems of equations. Our learning target is I can solve systems of equations by graphing, substitution, and elimination. Any of those three methods, that's what we're going to be learning today. So look at this first problem here. The initial cost for Travis and his band to record their first CD was $1,500. Each CD will cost $4 to produce on top of the $1,500. If they sell their CDs for $10 each, right here, how many must they sell before they can make a profit? So we're looking for their break-even point here. So the first thing we're going to do is this. Find the equation for the cost of the CDs. If X is the number of CDs that they're going to produce and sell, we'll let Y equal their total cost. So we're going to write our equation in slope-intercept form. Y being our total cost. It's going to cost $4 for each CD, so I'm going to say that's 4x. But they have an initial upfront fee of $1,500. So this is the equation that could be used to express their cost, total cost. If they make 10 CDs, I'd plug 10 in for x. 10 times 4 is 40. It'd be $1,500 plus a 40 or $1,540 just to make 4 CDs. So you want to make a lot of CDs in order to get some profit. The cost of the equations, the income of this, actually the equation for income of CDs would be right here. If they sell their CDs for $10 each, well, they make $10 for each CD. So how much money they're going to have coming in, that's Y again, would be 10 times X or 10X. Both these equations are in linear form, Y equals mx plus b form. You're either going up or down. In this case, it's $4 per cost, but there's $10 coming in. So you're making about $6 a CD, but you also have to figure in the initial $1,500. If you're going to graph both these, they're both in slope-intercept form. Here my y-intercept would be 1,500, and my slope would be 4 over 1. Here, I have no y-intercept. Actually, I do. It's 0. So it's this, the graph of this line is going to be going through the origin, but I'm going up 10 and over 1 if I was going to graph it. We actually do have a graph for this one. This would be tough to graph on your own. You can see your x-axis here is the number of CDs. Looks like they're going by 50, 100, 150, 200. And your y-axis is in thousands. $1,000, $2,000, $3,000. The point we're looking for is the break-even point. That's the point where these two lines are going to intersect, and that intersection is right here. That point is 250, 2,500. What that means is, just to break even, they're going to have to make and sell 250 CDs. And it would cost them $2,500 to make them, and they would receive $2,500. So at 250 CDs, after that, that's where they start making money, and that's this part of the graph right here. The cost is going up. The money coming in is going up, and here's the cost, but you can see there's a difference there. So that's where they start making money, is at 250 CDs. Systems of equations, 2 or more equations with the same variable. There's 3 ways to solve these systems of equations. Like we just did there, you can do graphing. So we looked at graphing a little bit. Also, we're going to talk about substitution. That's where you take part of one equation and plug it into a different equation for that same variable. And there's also elimination. A lot of the times you use elimination if you can, because it's a little bit easier. Some people get a little bit clogged up with substitution, but it works well in some situations. And you can also graph them. Types of solutions to a system of equations. First of all, your solution is always going to be this, an ordered pair. Some x and y value where your 2 lines intersect like they did in that last graph. The first type of solution is a system with one solution. Now what that means is you're going to have one x and y coordinate where the two lines intersect. They're going to be two lines that do not have the same slope, different lines, and you're going to be looking at that point right there. Down here there's some examples of the three different examples, and the one with one solution is this problem right here. You can see these two lines are two different lines and they intersect at one point. That's an x, y coordinate ordered pair solution. There's also no solution. And this happens when two lines have the same slope. If they have the same slope, they are parallel. And you can see these two lines down here are parallel. They never intersect, so it's no solution. So you would just maybe look at parallel lines. Okay, and the last one, infinite. Infinitely many solutions. And this looks like one line here, but basically when you have infinitely many solutions, it's when you have the same equation. Like one equation equals y equals 2x plus 3. The other equation is y equals 2x plus 3. They are parallel, but they also have the same y-intercept, so they're the same line. So it's a line on top of a line. So they intersect at every single point on the line, so that's why they call it infinitely many solutions. But most of the time we're going to be dealing with one solution, finding the point where the two lines intersect. So first we're going to start off by graphing. Here's a system. First equation is 2x plus y equals 5, and the other equation is x minus y equals 1. We're going to solve this by graphing. You have a couple different choices. You can graph in standard form, or you can graph in slope-intercept form. Standard form is when you find x and y intercepts. You find your x-intercept by plugging in 0 for y. So if I go up to this equation and look at it, and I plug 0 in for y right here, it'd be 2x plus 0 equals 5. Or basically, 0 plus 2x is just 2x equals 5. Divide both sides by 2, and I get x equals 2.5. So that's my x-intercept. 2.5. So 1, 2, 2.5 is right about there. My y-intercept is when x is equal to 0. So for the same equation, I'm going to plug 0 in for x right here and get 2 times 0 plus y equals 5. Well, 2 times 0 is 0, and I end up with y equals 5 for my y-intercept. Y-intercept, 1, 2, 3, 4, 5. And then you draw a line through it, and that's one way you can do it. Most of the time, I don't find x and y-intercepts. Some people call it the cover-up method because it's kind of easy. If you want to find your y-intercept, you can just cover up the x term. Well, you get y equals 5. If you want to find your y-intercept, if you want to find your x-intercept, you just cover up the y, divide both sides by 2, and you're going to get 2.5 again for your x-intercept. So that's one way you can do it. And if you have done it that way in the past, you definitely can. I generally put it in slope-intercept form, solve for y, and use my slope and my y-intercept. So if I take 2x plus y equals 5, and put this in slope-intercept form, which is y equals mx plus b form, okay? That means I solve for y. So I would have to subtract 2x from both sides here, and I get y equals negative 2x plus 5. So according to slope-intercept form, my y-intercept is 5. Well, we already have that from the last problem. And my slope is negative 2, or negative 2 over 1. So that means down 2 from your y-intercept, 1, 2 over 1. Down 2 over 1. Down 2 over 1. And you want to keep going as many times as you can. And draw a line through it. There's my first equation in red. This one is, you could use standard form, find your x and y intercepts, but I'm just going to do this. Solve for y. First thing I'm going to do is get y by itself, so I'm going to subtract x from both sides. Negative y equals negative x plus 1. I don't want negative y, I want to solve for positive y, so I'm going to divide every term by negative 1. When I do that, negative divided by negative is a positive, so I end up with y equals negative right here, divided by a negative 1, that's a positive 1x. And 1 divided by negative 1 is negative 1. So here's my line in slope-intercept form. My y-intercept is negative 1. And my slope now is up 1 over 1. Up 1 over 1. And I'm going to keep going here. I already know where the two intersect. I already know where my solution is, but I would keep going. So there we go. I have solved this by graphing, but you need to write down what your solution is. And once again, when you're solving systems of equations in two variables, x and y here, your solution is going to be an xy coordinate. Well, the coordinates of this point right here are my x's 1, 2, and up 1 would give me 2, 1. So the coordinates of my solution, the point where they intersect, is 2, 1. I'm going to show you in the next problem slope-intercept form again, but you can use standard form and find your x and y intercepts, or use slope-intercept form, whichever is more comfortable for you. Okay. Well, let's get busy with this one. I can see right now this is in standard form, so I might want to use x and y intercepts. But if I was, let's say I was going to find the y-intercept and cover up x there, basically plugging 0 in for x. 7/4 is what I'm working with. If I'm working with x and y intercepts, I kind of want them to be whole numbers. You can do decimals, but I'm going to put this in slope-intercept form. So 5x plus 4y equals 7. Solve for y. Subtract 5x from both sides. 4y on 4p equals negative 5x plus 7. They're not like terms, so I can't add them together. And then divide everything by 4. So y equals negative 5/4 x. I'll just leave this as 7/4. If you divide it, it's 1 3/4 or 1.75. That's going to be our y-intercept. It's not the best thing to work with, but we can make it work. So my y-intercept, first of all, 1 3/4 or 1.75 is right about here. And then from there, down 5 and over 4 for your slope. 1, 2, 3, 5, and over 1, 2, 3, 4 right there. Let me see if I can draw a nice line in there. Not the best line, but it'll work. My second linear equation here in this system is already in slope-intercept form. And if you notice something here, I have a slope of negative 5/4 here. I have a slope of negative 5/4 here. So they're parallel lines. They're either the same line or they're parallel lines. In this case, they have different y-intercepts. So these two lines are going to be parallel lines, which means I'm not going to have any solution. But to graph this first, 1, 2, 3, 4, down 1, 2, 5, over 1, 2, 3, 4. There we go. Two parallel lines, they don't intersect. So what's my solution? It's usually an ordered pair, but when they're parallel lines, it's no solution. These two lines do not intersect. And you can tell that just by looking at the slope. You wouldn't even have to really graph this one. The next thing we're going to learn is substitution. Solving system equations by using substitution. There's some steps there, but the main thing with substitution is one of your equations needs to be solved for a variable. If you look up here, the first equation is solve for y. What does that mean? It means I can plug in the expression part of what y is equal to, this 1/2 x minus 18. That's the expression part. that's equal to y. So I can plug that in for y in the other equation and then solve for just x because that's all I have left in the equation. This is substitution. So my second equation I'm going to rewrite x plus 2y. But I'm saying y is now equal to what y is equal to in the first equation. 1/2 x minus 18 equals, this whole equation is x plus 2y equals 18. So I got to put an 18 over here. And you can see now, all I have is x's. This is substitution. I could have solved for x and plugged that in for x in the other equation, but this one's set up for us where it's already solved for y. So basically now once we plug that in, that expression part for y, we just solve. So we're going to simplify first. 2 times 1/2 is 1, our x. 2 times negative 18 is negative 36 equals 18. This is 2x minus 36 equals 18. We are going to add 36 to both sides, and I get 2x equals, looks like 54. It's finally solving for x, divided by 2, I get x equals 27. Now, what a lot of people do, a lot of students I say, is they say they're done, I've solved for x, but this is a system of equations. Your solution is an ordered pair, an x, y ordered pair. Our x in this case is 27. Now we need to find the y. Well, how do we do that? Well, you know x is equal to 27, so you just plug it in to one of the other two equations for x and then solve for y. Being this first equation here, if I can clean it up a little bit, it's already solved for y. I'm just going to take x and plug it in right here and then simplify and solve. Y equals 1/2 x, but x is now 27. And minus 18. 1/2 times 27 is 13.5. You just do that on your handy dandy calculator. And y equals negative 4.5. So you could write your answer like this. Hey, there's my x and there's my y, but I prefer you to write it as an ordered pair, just like this. And that's substitution. So, word problems, and this is where we get a little freaked out. It just takes time and a little bit of practice. This is kind of a straightforward word problem because the two equations are going to be one dealing with money and one dealing with some kind of an amount. In this case it's gallons. Could be anything, but usually there's a money equation and a total amount equation. So let's read this first and talk about it. Matthew stopped for gasoline twice on a long car trip. The price of gasoline at the first station where he stopped was $2.50 per gallon. At the second station, the price was $2.65 a gallon. Matthew bought a total of 36.1 gallons of gasoline and spent $94. How many gallons of gas did Matthew buy at the first station? Well, basically we're looking at how many gallons did he buy at each station. Well, 36.1 altogether. We'll say the first station, he bought X gallons of gas. At the second station, he bought Y gallons of gas. So here's where we start setting up our equations. There's two variables, an X and a Y, so I need two equations in order to solve for it. There were 36.1 gallons bought altogether. So if I take X and Y, the number of gallons at the first station plus the number of gallons at the second station, that should equal the total number of 36.1 gallons. Okay, here's where the money one comes in. Well, he bought X gallons at the first station, but it's $2.56 per gallon. So it's 2.56X. That's going to be the total money amount he spent at the first station. Plus, it was $2.65 at the second station, so 2.65Y. If I add these two money amounts together, I should get $94. So here's our system, and we're going to solve it. And all we really know right now, I would probably use elimination on this, but I'm going to show you that you can use substitution. It has to be solved for one of the variables. Well, Both of these equations are in standard form. There's an x and a y on both sides. Which one would probably be easiest to solve for one of the variables? Well, if I subtract y from both sides in the first one, just subtract y from both sides, I'll get x equals 36.1 minus y. Well, I could have solved for y or x. I solved for x though. So now I can take this and substitute it in the other equation for this x variable right here. So I'm going to have 2.56x, but x is now equal to 36.1 minus y plus 2.65y equals 94. Okay. So now I need my calculator here. See if I can get this bad boy up here. And we're going to do some a little bit of work here. First of all, I need to multiply 2.56 times 36.1. What do we get? 92. And then we have 2.56 times negative y, just using the distributive property here. I'm going to get negative 2.56y plus 2.65y equals 94. So, cleaning this up a little bit, I'm going to get 92.416. I have more positive than negative. How many more? Well, 2.65 plus negative 2.56. 0.09. 0.09 we'll say y equals 94. So subtracting 92.416, a little bit of work in this problem. I get 0.09y equals, okay, subtracting those, 94 minus 92.416, 1584. And then just dividing both sides by 0.09. $17.6 gallons. So y equals 17.6. So let's go back up here. The actual question they're asking for here is how many gallons of gasoline did Matthew buy at the first station? Well, we know this. At the second station, y equals 17. What do we have? 17.6. That's the second station. So if we gave that for an answer, say like on an ACT, we'd get it wrong. Even though we did all this work and did it right, we need to, there's 36.1 gallons altogether. We need to subtract 17.6 from it, and that gives us a grand total of 18.5. Yeah, 18.5. That's how many gallons you'd have at the first station. So be careful what answer you're looking for. Our actual answer is 18.5. Okay. Do it here for a minute. And there's an example of substitution with a word problem. Now we're going to get into elimination. Elimination I like a little bit more than substitution. It seems like it's a little bit easier for some kids. Sometimes it's pretty quick to solve. What elimination is this. If you add your two equations together and you can eliminate one of the variables, it's easier to solve for the other one. And then you're halfway done with the problem. But you got to have two variables that are opposite of each other. 4x and 2x are not opposites of each other. If I added those two up, I'd get 6x. But what about 2y and negative 2y? Well, they cancel each other out to 0y or just 0. A lot of times with elimination, you have to multiply your equation through by something first in order to get the variables to be opposites of each other so you can actually have them together and cancel out. But this one's pretty easy. Adding up the columns. They have to be in standard form. X is in one column, Y is in one column, and then that's equal to your constant. Constant is just a number by itself. 15 and 9 are what we call constants. So add them up. 4x and 2x, that adds up to 6x. The 2y and the negative 2y, they basically cancel out. They add up to 0. I'm not even going to write it down. Equals 24. 6x equals 24 is a simple equation to solve. Divide both sides by 6. X equals 4. And a lot of people right here would quit. But you're solving a system, two equations, two variables. Your solution is going to be an ordered pair. And our x value is 4. So we're halfway done. We're not completely done here. We have to find our y. So what we do is just take x equals 4 and plug that in for x in either the first equation or the second equation. I'm just going to plug it into the first one because it really doesn't matter. So I get 4 times 4 plus 2y equals 15. This is 16 plus 2y equals 15. Subtracting 16 from both sides, I get 2y equals negative 1. If you divide both sides by 2 here, you get y equals negative 1/2. Okay, you could write your answer like this. Just circle both your answers. I'd rather have you write it as an ordered pair so I can find it nice and easily. These two lines will intersect at the point for negative 1/2. That's elimination. Here's elimination that you probably see more of. It's a little bit more complicated. If you were to add these two equations together right now, the way they're set up, 2x plus 3x is 5x, and negative 4y and negative 1y is negative 5y, equals negative 50. Well, I didn't get rid of either one of my variables, so I'm going to have to do some multiplying here, manipulate this problem a little bit. And sometimes I look at the x's or the y's and say, well, does 2 go into 3 evenly? No. I'd have to multiply by 1.5. I don't want to do that. I think, well, 2 and 3, what do they both go into? A lot of people would say 6, yeah. So here's what I'm going to do. I'm going to multiply this top equation, both sides, the whole equation, each term in the equation by 3. When I do that, I'm going to get 6x minus 12y, right here, multiplying it by all 3, and then 3 times 26 is going to give me negative 78. The bottom equation, I'm going to multiply by negative 2. Why negative 2? Well, what's negative 2 times 3? That's negative 6x. These are opposites of each other, so when I add them together, they cancel out. Negative 2 times negative y is positive 2y. And negative 2 times negative 24 is positive 48. Adding these two together, my x's will cancel out. Elimination, that's what you want. Negative 12 and 2 is negative 10y equals negative 78, and 48 is negative 30. Divide both sides by negative 10. Y equals 3. For my solution, I need an x and a y. Right now I have the y. Sometimes you solve for x first, so you write the 3 up there right away for the x, but it's y equals 3, so make sure you put it in the right spot. And then I'm just going to plug in that 3 for y into either one of these equations. I don't know, I'll pick the bottom one for whatever reason. 3x minus the 3 for the y equals negative 24. I'm going to add 3 to both sides. I'm going to get 3x when I do that equals, these cancel out, negative 21. Dividing both sides by 3, x equals negative 7. There you go. Now, I showed you that way because that's multiplying both equations by something. Sometimes that'll happen. Sometimes you're going to have to do that. But I do want you guys to notice this, and maybe some of you already have. Mr. Prakar, why couldn't I just have multiplied the bottom by -4? Well, why would I do that? Well, the top equation I'm not going to multiply by anything. 2x minus 4y equals -26. -4 times 3 is -12x. But -4 times -y is positive 4y. Equals 4 times 24 is 96. It's positive 96. And you can see when I add these two together now, my y's cancel out. So sometimes you only have to multiply one equation by something in order to add them up and eliminate a variable. I get -12, or -12 plus 2 right here is -10x equals, what do we got here, positive 70. So solving this, dividing both sides by -10, x equals -7. So you could have solved it that way also. I'm just showing you the two different ways when using elimination. Sometimes you have to multiply one equation by something, sometimes you have to multiply both equations. But whatever works best for you. In order to practice at home, Sammy purchased a basketball and volleyball that cost a total of $67, not including tax. If the price of the basketball is more than twice the cost of the volleyball, find the price of each ball using the system of equations. Well, basically what don't we know? The cost of a volleyball and the cost of a basketball. Some people would use X and Y here. I'm going to use V for volleyball and B for basketball so I know what I'm talking about. I think it works a little bit better. A lot of times one of these equations is very easy to set up. V is the total cost of the volleyball, B is the total cost of the basketball, but if I add them together I get $67. So V plus B equals 67. Okay, the other equation is listed right here. If the price of a basketball is usually your equal sign. So I could say basketball, the price of the basketball is or equals 4 more, that means I'm going to add $4 to twice the cost of the volleyball. Twice the cost of volleyball plus 4. Or you could have 4 plus 2v. It's the same thing. Now, I have two variables, now I have two equations, so now I can solve this system. What would I use here? Graphing? Probably not. Substitution? Well, yeah. It's solved for b right here. I know that b is equal to the expression 2v plus 4, so I can plug that in for this b in the other equation. So v equals, I'm sorry, not v equals. We're going to rewrite this equation with a new b. V plus, what b is equal to now? 2v plus 4 equals 67. Okay, v plus 2v is 3v plus 4 equals 67. Now I'm going to subtract 4. 3v equals 63. If I divide both sides by 3, I'll get v equals 21. What does that mean? The cost of a volleyball is $21. So what's the cost of a basketball? This is probably, well, either one of these equations would work well. You could plug 21 in for v up here and just subtract 21 from both sides. Or you can plug 21 in for v right here. I'll do that. b equals 2 times 21 plus 4. Okay, so that means b is equal to 42 plus 4, or the price of a basketball is $46. And they wanted both answers, so there we go. If you have any questions, let me know tomorrow. You can come see me individually, or I'll probably be giving a short lesson on some of these problems. Peace out, a Girl Scout.